Assalamu alaikum. My name is Muhammad Muslim and my group members is Muhammad Ali Bud, Armaganur Rahman and Muhammad Rizwan. Our first question is exercise 3.9, question number 3.4, in which we modify the program and print the line of output of each process. So the output is printed in process rank. इसमें हम ऐसा करेंगे कि आउटपुट इसकी जो भी प्रिंट होगी मॉडिफाई करके वो सीक्वेंस के साथ होगी, मसलन के पहले प्रोसेस 1 होगा, फिर 2 होगा, फिर 3 होगा। इस प्रोग्राम में हमने ऐसे किया है। और एल्स कंडीशन में हम प्रीवियस रैंक और सेंड द नेक्स्ट वन इफ दिस नोट द लास्ट वन ऑलरेडी। इसमें हम रैंक अगर कम्युनिकेटर साइज से n-1 होगा तो वो लीस्ट प्रोसेस होगा और उसे सेंड कर देगा, और बाद में MPI फाइनलाइज के फंक्शन को कॉल करके रिटर्न कर देगा। नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 3.8, part number A, in which we draw a diagram in which show MPI scatter implement using tree structured communication with communicator size process when process 0 need to distribute and array container and elements. इसमें हमने स्कैटर प्लॉट ड्रॉ करना है जिसमें हमारे पास कम्युनिकेटर का साइज 8 है और प्रोसेस नंबर ऑफ प्रोसेस जो है n16 है। The vector element are distributed so that they all have the amount of communicator size is equal to 16/10, जो कि हमारे पास 2 हो जाएगा, जो हमारे पास ईच प्रोसेस के साथ मल्टीप्लाई होगा। जैसे कि बॉटम में 2 है और वो 2 के साथ डिवाइड होगा तो मल्टीप्लाई होगा तो 4 आ जाएगा, 4 के साथ 2 मल्टीप्लाई होगा तो वो 8 हो जाएगा, और 8 के साथ 2 मल्टीप्लाई होगा तो वो 16 हो जाएगा। ऐसे हमारी ये डायग्राम ड्रॉ हो जाएगी। ईच नोड के साथ हमने ऐसे करना है और एंड में हमारे पास रूट में 16 आ जाएगा। बी पार्ट में हमने ड्रॉ डायग्राम्स MPI gather can implement using tree structure communicator an element array has distributed among communicator size। इसमें हमारे पास डिस्ट्रीब्यूट होंगे कम्युनिकेटर साइज के प्रोसेस that gather output onto the process 0। all the process has to send their element to process 0, process 1 send element to process 0। सब प्रोसेस अपने एलिमेंट्स 0 को प्रोसेस 0 को सेंड करेंगे, और प्रोसेस 1 सेंड इट्स एलिमेंट टू प्रोसेस 0, प्रोसेस 3 सेंड इट्स एलिमेंट टू प्रोसेस 2 एंड सो ऑन। एंड ये डायग्राम ऐसे ड्रॉ हो जाएगी। Now problem 3.9, in which we write a program MPI program that implement multiplication of a vector of scalar and dot product. The user should enter two vector scalar all the which are read into process 0 distribute among the process। इसका solution है, this program working principle is given by multiplication of vector 1 by the scalar and the product of the results with vector 2 and vector 1 are the split with MPI scatter between the process, and each vector location 1 and location 2 are manipulated to later have their results summed by the MPI reduce। ये कोड MPI का कोड किया हुआ है। MPI की लाइब्रेरीज में पहले बिल्ट इन लाइब्रेरी इंपोर्ट की गया, उसमें हमने मेन फंक्शन में वेरिएबल्स बनाए हुए हैं वेक्टर्स के, वेक्टर 1 वेक्टर 2 के, और कम्युनिकेटर साइज और रैंक दिया हुआ है इसको। कम्युनिकेटर साइज में उसका कम्युनिकेटर का साइज आएगा और रैंक में उसका रैंक आएगा। अगर रैंक 0 होगा तो नंबर ऑफ वेक्टर्स प्रिंट हो जाएंगे, और स्केलर वेक्टर हमसे यूजर मांगेगा। अगर नीचे इसका आउटपुट ऐसे होगा, अगर हमारे पास नंबर ऑफ साइज ऑफ वेक्टर 4 होंगे और स्केलर 2 होंगे तो फर्स्ट वेक्टर होगा 1579 और सेकंड वेक्टर 2316 होगा और रिजल्ट 156 आएगा इसका, और इसका एग्जीक्यूशन टाइम 20.233 सेकंड्स है, ऑलमोस्ट 21 सेकंड्स है। नाउ अरमगानुर रहमान एक्सप्लेन नेक्स्ट क्वेश्चंस।
Assalamu alaikum. My name is Armagan Rahman, and now I will explain the further questions. The first question, which is 3.12, is about the butterfly structure. So in this, we have to modify the algorithm for all reduce in A part, and in the second part, we have to modify the program to implement prefix sums. So in the first we use int global sum the function, then the variables, then we use MPI send receive commands and the whole program, and then we use else if, and after that we use for loop, and then we use again MPI send receive replace statement and the further code. So after modifying this, we can get for all reduce in the butterfly structure. And in the B part, we write the same code for that, but we did slightly change for using prefix sums. Next question. In the next question, we have to modify the MPI program for modify your vector sum dot so that it can correctly correctly handle the case when n is not divisible by communicator SZ. So here is our code. First, we have a function Jaras and counts where we have the arguments, and then we have the variables, and after that we have for loop in which the statements are given for our program that we have modified. Next question. In the next question, we have to write a serial C program that defines a two-dimensional array in the main function, and we have to use only numeric constant for the dimensions which we have given in the question, and we have to initialize the array. So first it is asking that after writing the function, try to compile it. Can you explain why it won't compile? And in the B part, it is we have to modify the program so that it will compile and run, but so that it still uses a dimensional C array. So in the first part, a two-dimensional array is a 2D pointer, so it does not allocate memory without knowing the second dimension of the array. So first we have the header files, and then we have the function print print two-dimensional, in which we have the arguments. Then we have the main function in which there are two-dimensional array variables, for loop, two for loops, and then we are multiplying the array, and then we have the print two-dimensional array function. So this is our program for A part. Next. And in the B part, we have modify our program void print two-dimensional in for of this function, so we can get the our required result. Now now Mohammad Ali Bhatt will explain the further questions.
Assalamu alaikum. My name is Mohammad Ali Bhatt, and I would like to explain the question number 3.16, which have suppose communication size is 8 and the vector x is equal to 0 to 15 has been distributed among the processes using a block distribution. Draw a diagram illustrating the steps in the butterfly implementation of all gather of x. So you can see that in this question, we can draw a diagram with the which illustrate the butterfly implementation, and we know that if they had a communication size is 8, so they have 8 blocks in each columns, 8 rows, and there have four rows, four columns and eight rows. So in this situation, we know that there have the communication size is 8, which has 8 rows, and the vector size is 0 to 15. So 0 to 1 is the block, and 2 to 3, 4 to 5, 6, 7, and so on. And according to the next column, 0 to 3, 0 to 3, and 4, 7, 4, 7 is the same rows column. And in the third column, 0 to 7, 8, 15, and the last 0 to 15. So we can separate all the vector numbers which have 0 to 15. So we can separate it. You can see in the diagram. So the next question is 3.22. This question time our implementation of the trapezoidal rule that use MPI reduce. How will you choose and the number of trapezoids? How do the minimum times compare to the mean and median times? What are the speed ups? What are the efficiencies on the basis of the data you collected? Would you say that the trapezoidal is rule scalable? So we say that the trapezoidal rule is efficient, is can increase the speed ups, and it is scalable. So in this code, we include the libraries stdio.h, mpi.h. Now we call the function word build MPI type, which have MPI data type, input MPI type, and tuple. In this code, we have initialized the array, which have block length is 3, which have hard coded values, which has 1, 1, 1, and the MPI data type array in the next line. MPI data type array of type is 3. MPI double MPI, MPI double, MPI double, MPI int. We have two doubles and one integer, and we have in the third line we have three integer, three values, which have int a, addr b, addr n. So in this code, it shows that the block of three size which have get address of the reference of a, b, and n, and in the last line of the code, it shows that the array of the block lengths, so it can be communicate with each other. And in the second function void get input, in this function we only get input of communication size of rank. Third function is the trap function, which has used to barrier the trap the threads, which we can use to for parameter left, right, and trap count. So it's so this function is trap and count and estimated the base and length. So now the last function is f, which have return the multiplication of x. In the main function, we have the uh, parameters, initialize the variables int by rank, communication size, and local length. So this code is shows the reduce the communication size. This code shows the we will input the rank, communication size, a, b, and n reference, and we can use the barrier MPI barrier function, and we can use the reduce function for maximum time, medium time, and average time. So it can finalize in the end of the program. The output of this program is minimum time spent, maximum time spent, average time spent, and medium time spent. So we can using this formula, s is equal to t serial t parallel, e is equal to sp t serial t parallel. So the if we run for a is equal to 0, b is equal to 1 lakh, and the n triple I is equal to 1 crore. So the uh, this table shows the minimum, maximum, average, serial time, and parallel time. The series result of the different n trapezoidal values from 0 to 1 crore. So number of trap is 5, 10, 20, 100, up to so on, and the result, speeds up, and efficiency are given. So cyclability tests are 2 processes and 100 trapezoids are 2, and the 4 processes and 200 trapezoids are 4 to 25. So in the outcome, introduce the base worth is very a very long way for the normal worth being dependently the best execution case conceivably. This is definitely not a decent measure. The trapezoidal rule is not versatile in the light of the fact that by multiplying the quantity of processors and the size of the issue, the productivity has not been kept steady. The next question is 3.23. Although we in this question we use the implementation of MPI reduce, we can use the structure of binary tree. If this is the case, we have expect the runtime we have to growth, and we should use the log 2 levels in the tree. We can use the trapezoidal serial rule, is roughly proportion. So in the A part, we show that the number of trapezoids is 20 to up to so on 1000. So and the number of trapezoids is depend upon the time. So you see that the 20 time is 2,98 multiplied by 10 powers minus 7, and the 1000 trapezoids time is same, is minimum minus 6, using the least squares rule in Wolfram. So we use the least square method. We have do we have used the different columns and rows and least square method using the Wolfram. The first column of the matrix is n over p, and second column is log 2, where p is always 4.0 and a is equal to 0.08348 multiplied 10 powers minus 7, and b is equal to 1.84 multiplied 10 to the minus 7. So in the b type, number of trapezoids is 20 to up to so on 10,000, the real time and the estimated time. So the predicted result are satisfactory, and it's very likely that the implementation of MPI Reduce has been in a binary tree as the books pose. Now I would like to call Muhammad Rizwan to explain the programming assignments.
My name is Muhammad Rizwan, and now I will explain furthermore now programming assignment 3.10. We'll start with the question number 3.2. And in this program, basically, in this assignment, I want to explain about the MPI. MPI is basically a technique or method to create multiple values regarding characters. As you see in this display section, first of all, we use preprocessor directories that already included in as a library file. Then we initialize a variable like n with the data type double, and then we further declare a randomly double value or a variable which name is n, and then we also declare a variable. This name is rand max, and then we give a particular value, and then we use condition random max is less than 4, and if we use one more variable with the given condition, if the given condition is true, like rand max is greater than 4. When the number of times rand max is greater than 4, less than 4, then it move to the body of the function and execute and multiply by equal to minus 10, return n. And then we use a MPI as a built-in function to declare a variable p which data type is in character, and then if both of these line amp void return type is declare, then execute or declare, then it move to the body of the function and execute the printf and display usage colon, and then given value after execution, and then exit 0 if move to the if the given condition is true, and move to the 0. And if the given condition is false, then it directly moves to the void main integer argument, and then character type argument c and argument b. Both of these are different variable with a different data type, and then move to the long integer num with the character, and then declare one more 2 to 3 variable like t and c I with the integer data type and double. And after this all the execution, we used if condition in the last or second last, and its name is dst, If DST is less than equal to 1, when the number of times the given condition is true, then it directly move to the body of the function and execute the num CR plus equal to 1. Double pi is equal to 4 multiplied by num, that CR double num tossed. If all the values are executed, then in the last we also execute a output statement, that is printf, that is estimated value is given to the percentage 14f. 14f is basically a format specifier for the floating data type, and backslash n is show that the given answer, integer, integral or float answer, is moved to the next line. And pi is basically a variable that store all the values of the given result. Then move to the question number 3.4. In this question, basically, we first of all we use two preprocessor directory. The first one is hash include, and the second one is the hash define. Hash include is basically a preprocessor directory in which we use a man-made, or in which we use a built-in library files. And hash define is basically a preprocessor directory in which we declare user-defined variables or character or data types. Like array size is basically a user-defined. It show with the hash define, and its given size is 1,48,576 is a given value, integral value of the variable array size is basically the size of the array. And then integer main is basically a function main, yeah, main of the function, in which we use two variable as we already declared in the above example, integer every argc and character argv. So then we declare two more variable with the data type integer, rank and size. If MPI is given, if the given condition is not equal to or equal to MPI success, then it move to the body of the part f printf, and then execute the given condition that return in printf statement, and then return -1 if the given condition is true. And if the condition is not true, then it will return 0. MPI communicate rank, or MPI communicate size. Is basically both of these are the rank and the size of the MPI that we use in the above example. And then we use array size, and given array size is directly mode with the we use mode, and size is not equal to 0, and rank is equal to basically both of these ampersand show the and operator, and then rank is equal to 0. If the given all the logical operator combines the variable condition is true, then it moves to the printf statement and execute the array size. And if the condition is true, then it returns 0 -1, otherwise it show represent return 0. MPI then we check out the status of the MPI. If the given status is true or false, then we use array and the chunks with the integer data type, and then MAL LOC basically memory allocations to define the integer variable size, and then integer I is equal to 0. This I is equal to 0 is declared in two time, one before the for loop, and one inside the loop, to show the one variable I. I is basically a variable counter to count the number of the array size, or number of duration or repetition. If the given I is less than array size and incremented with the one time, I plus plus basically show the I is equal to I plus 1. And then we if the given loop is true in the different number of times, at least the given condition is not false, then it move to the body of the loop and execute both of these line, like array I. Array I is basically the size of the array I, first of all in 1 0 2 3 and up to so on. And then we are use combine calculated with the 1024, and then total is equal to sum plus equal to array I. It's a shortcut way to write the total sum is equal to total sum plus array I. And then MPI barrier and scatters, both of these are further two more functions to identify, to clarify further explanation. And then we use integer if conditions that receive the EMPI values, and then we use again declare one more variable that is a temporary and cover our conditions. And if the given conditions are true, then directly move to the downside and execute furthermore. In this portion, basically, we create an array of random numbers because we want to find out some random numbers that we execute in our program. And if the random numbers are not equal to null, it means the given condition is true, then directly move to the for loop and execute the for loop, and then use integer main portion. Furthermore, in this integer main portion, we use if statement based on two variables that we already discussed in the top of the program, that is argc is not equal to 2, then the given condition is true, and print if statement execute and exit one number. And then AMPI initialize two more variable, and then create a random array of the element on strand times and some and then sum the number of sum all the numbers locally. We also declare a one variable local sum is equal to 0, initialize with the 0, and then use for loop, reduce all the local sum into the calculation for the mean. Then we use all reduce variable to calculate the reduction of this variable, and compute the local sum of the squared number, and then reduce the global sum of the squared, and print it one by one. We are also represent the different specific portion with a comment sign that more clarify our concepts, how we combine all these program, and to explain furthermore. And then we use a butterfly structure. Butterfly structure is basically a structure of programming statements or programming language that is used in many situations to particular calculate as we need to communicate to all processes in the communication groups. But first of all, we must follow some basic points that I easily be able to identify with the bold signs. These does not use any of the available parallelism. This structure is to be implemented with the similar scheme of the structure. This means that is used in tree structure, but with the similar situations, with a very smallest part of the program, like subprogram or a function. These pairing are created in an executive or an operation to perform different calculation and give you a particular result according to your processing. And they're terminating with a different communication multiple times with a for loop or a while and many other loops that may help you to execute with the multiple times. Butterfly communication is basically written in this structure like as you display on a screen. A global sum is basically a method to be a rank, and then integer sum, integer count, integer temp, and then integer partner. Both all these are the different variable with a data type integer, and with also we also initialize with the integer values. And then unsign is basically also a type of integer with a no sign. And then we use while loop at the end of this program, and if the given condition while loop is less than p, the variable bit mask is less than p, the given condition is true, then move to the executable statements and execute all the body of the parts statements, and then calculate and give you some result. And this result is stored in some variable, and return statement is used to return the sum variable. And then return state some basically a global variable because it declare inside the body of the function. Okay, thank you so much.
So in this video, we will discuss about the homework 4, which is based on the MPI. Thank you.